true statement, then that point, along with every other point above the line, is part of the region that we call the feasible region, holding all the solutions to the problem. If that's not true, then that point and all of the points above the line cannot be in the shaded region. It must be the other side of the line. So, last time I checked, 6 plus 6 was not less than or equal to 6. This is a false statement, right? So we do not include this section. This is not included in the shaded region. Instead, what we would end up shading would be everything that would be on this side of the grid. And the program will automatically fill that in when you pick the right set of tools. Okay, so you don't have to get a true statement out of your test point when there's only one line, because if it wasn't the side that you wanted, it had to be the other side of the line. And you get to pick the point that you want. Make life easy for yourself, okay? Now, where does that show up in the homework set? I think it shows up on problem number 4 as the first one that we get. There we go. Not quite. Oh, by the way, again, one other trick. The graphing window that's going to pop up when you enlarge the graph is a percentage of the window that the test problem is in, or that the homework exercise is in. Suggest that you maximize that window so it takes up the whole screen, so that your graph window is going to take up more of the screen. Otherwise, it's going to be hard for you to work in the graph. Okay, so this problem is not quite set up the way that we would like to have it, but we can still do it. Most of the problems we get are going to be like this in an intercept form. But some of the problems are going to show up like that. So just to cover both bases, we have a y equal mx plus b format. Now here, I can still do the same kind of things in terms of picking points, but when I click this graph, I can't change the size of this window. I'm stuck with that, which is why we want a bigger window that your test problem's in. Part of the reason we ask you to maximize your grids when you're taking the test. So I need to do what it says, click the graph, choose a tool from the palette. Well, our first tool is the line tool. Now that's going to allow me to be able to plot points, and I know we talked about this before. In the upper right-hand corner of that yellow bar, you see the coordinates of the point, so it should be impossible for you to put the point down in a wrong place. But I need some points. So the problem is set up to be worked with us picking values of x. What can we pick for x? We could pick 0. Could we pick 1? Could we pick 2? Could we pick 3? So what can you pick for x? Anything. It's your choice, as long as it fits on the grid, or the result that's on the grid. So if you want x to be equal to 0, 0 plus 7 would be 7. So your point is going to be 0 and 7, because when you chose an x value 0, you came up with a y value 7, nail that point down. Now your line's alive. All you got to do is figure out where a second point happens to be. So I need a second value of x. What could you use? Anything. What are you going to use for this problem? 1, that's fine. 1 plus 7? 8. So now you have a point 1,8 to graph. Pretty close. By hand, we might not do it that close because it's harder to get them close together, but the program doesn't care. So, nail it down. Now, second step, is the line included or is it not included? The default was included, but if you have a strict inequality that doesn't have the or equal to phrase to it, then you would have to select dotted line. And if you select dotted line, see how it changes it to a dotted line. Okay, so this was a solid line. Now we need to do our point test to find out which side is going to be shaded. You need to clearly pick a point that is up here or a point that's clearly down here. Your choice. What point do you want to use? 0, 0? 0 less than 0 plus 7. So here's the question we're asking ourselves. Is 0 less than or equal to 7? So that's either true or it's false. In this particular case, it's true. So since it's true, that point is one of the infinite number of points that are part of your solution. So we shade the side of the graph that contains 0, 0. Region shading tool, your bucket list. You select the bucket, you move it clearly into the region that holds the point 0, 0. Don't get it too close to the line because it does funky things when you sit it right on the top of the line, and it may look right, but it will be counted wrong by the program. So make it clearly in that section. Doesn't have to be here, can be over here, can be down here, can be over here, just as long as I'm clearly below that line. Click it, it shades, save it, check it, and go to the next problem. Simple as that. They're not all like this, but a good majority of them are like this.